I'm going to talk about, my title is Bacteria, Books and Populations, and you've already heard a certain amount about the many things that Luca did, and it's really a bit of an excursion as to the things I was involved in and also some of his earlier work on bacterial genetics. The next slide.
I cannot hear you.
You can't?
It is better perhaps to use this.
Okay, I will use that.
Yeah.
Is that all right now? Okay. So the next slide shows Luca as I remember him, looking jovial and in a very happy state. Now, on the next slide I want to show you, because it's almost exactly 62 years ago that I first met Luca. He'd come to see R.A. Fisher, with whom, as you know, he had a major interaction and eventually came to work in Cambridge. And he came to see Fisher because of his interests in quantitative genetics. As you probably know, he was offered a job at very short notice by R.A. Fisher at a meeting in Stockholm, and that was around 1948. And Fisher had become interested in bacterial genetics, and he had the foresight to realize how important that would be for further genetic analysis. And that's why he offered Luca a job, because he seemed an ideal person to combine the bacterial genetics with the quantitative aspects. And as you see, this is actually my awful handwriting, and it says that he was really, he offered to send me data, and he was really a lovely person. And I want to say that for an academic type of interrelationship, you could have said that that was sort of love at first sight, although it was only requited some 5 years later. Well, the next slide goes on to say something about his bacterial genetics work, which is not always as much recognized. He'd started actually with Magni and Visconti with an interest in working with bacteria, looking at resistance to ultraviolet light and antibiotics. And he became aware very early on of Joshua Lederberg's famous work published in 1946 that showed that you could do genetics with bacteria. And quite remarkably, at that time, he wrote to Josh, as we called him, and asked him for some of the strains. And his very early work showed that there were actually mating types between E. coli, which had not been realized, and that you could take a type F+, and it would mate with F+, and it would mate with F-, but F- could not mate with other strains, and this was a very important discovery. And on top of that discovery, you'll see how you can see it on the line. He found through experiments on using mutagens that he found a strain which actually did this mating process at something like 1,000-fold greater rate. And he called that, he says, la caratteristica del ceppo, he called it the high frequency of recombination strain, HFRs, which became very important in the eventual development of bacterial genetics. And he shared this work with Joshua Lederberg, and for a number of years they exchanged ideas and worked together without them ever having been met. And I have to say that I share uniquely with Luca a remarkable association which he had and which I had with both R.A. Fisher and Joshua Lederberg, who are possibly two of the most remarkable scientists of the 20th century. But in addition to these fundamental studies on the genetics of bacteria and how they worked, and the next slide please, he had a remaining interest in trying to do quantitative genetics, which he had become interested in, and that's how actually he met Fisher through having worked with Kenneth Mather, who was one of the pioneers of polygenic inheritance, who was actually my PhD supervisor. So they attempted to do quantitative genetics on antibiotic resistance in bacteria. And it was quite a remarkable study, because it was one of the few studies where people tried to see whether you could work out if there were multiple genetic steps that were involved in giving rise to resistance, as illustrated on in that diagram. And in fact, some 6 years later, I had similar ideas based on what he'd done to do similar work with Neurospora. Luca had worked in a sort of adjunct glass house to the Department of Genetics in Cambridge, and there was a refrigerator there in that. When I started wanting to do my own work in the laboratory, I opened it, and there was the glassware that Luca and Makakara had used 6 years before, which I was able to use to start my own studies. But Luca did one further very important piece of work, in my view, on bacterial genetics. And this was the one time that he actually worked with Joshua Lederberg in Madison on a Rockefeller Fellowship. And there was a lot of actual skepticism about whether genetics really could be done in bacteria, and whether the resistance to antibiotics, which had become evident, was not due to the effect of the antibiotic, rather than to pre-existing mutant bacteria. And Joshua Lederberg, with his wife Esther, had devised a procedure called replica plating, in which you could identify colonies of bacteria that were resistant to antibiotic without ever having been exposed to them. But Luca wanted to develop a more quantitative approach, and they devised something called SIP selection, which is actually based on the way that you select for animal improvement, for improvement in milk production or meat production in animals, by selecting the animals that gave the best progeny for that purpose. And they devised a procedure where they did the same sort of thing, but using the SIBs of selection. And I don't know whether you can see that. The idea was that if you diluted the bacteria enough, you might find some cultures that had an occasional resistant organism. So if you sampled a set of small cultures, took a sample out, and see what the frequency of the antibiotic resistance was, you could identify the cultures that had got in them, without having ever been exposed to the antibiotic, a resistant organism. And those are the ones indicated by those two big arrows. And then eventually, by producing that, going through it several times, you could get to a stage where you would pick individual colonies off a petri dish that had antibiotic resistance, but had never been exposed to the antibiotic, which was an important and very elegant demonstration, eventually, that there was no doubt about the genetic basis of antibiotic resistance. Well, although Luca continued, as many of you know, with some studies in bacterial genetics, gradually throughout the 1950s, he decided to move into human genetics. And that's, of course, what nowadays he's often best known for. And the next slide, which shows his 4 most cited publications, which are all to do with population genetics, human population genetics. You'll hear more about them. I'll say a little bit. The remarkable book with Cavalli-Sforza and his colleagues on the history and geography of human genes, the phylogenetic analysis, which was pioneering, the cultural work done with Mark Feldman, my former part student, I'm sure you won't mind my saying that, and then the book that Luca and I wrote together on the genetics of human populations. And I want to say a little bit about the origins of this, because I think it eventually became much more than just a textbook. Lederberg, who got to know Luca, of course, by that time, had invited Luca to give a summer course, rather as the courses we heard about, on statistical aspects of genetics at Stanford in 1960, the summer of 1960. And then Josh asked him again to give the course again in the summer of 1962. And by that time, I'd become a postdoctoral fellow and then got a junior faculty position with Lederberg, who had been interested in my work in population genetics and suggested that perhaps Luca and I should give the course together, which we did. And that course was eventually the basis for writing this book, because we thought, having put the effort, oh well, it would be quite easy to make a book out of it. That took another 9 years. Now, the next slide shows that you probably recognize that if you know Pavia. That's Luca and myself, obviously, when we first started talking about writing the book in 1963. And there were a number of other occasions when we got together, when I would come to Italy, and we would talk about the book and start writing on it. But it was really not until he finally came on a sabbatical, as many of you know, to Stanford in the year 1968, 69, I think it was the year, or 69, 70.
Yes.
It was 68, 69, when we really got down to writing the book together. And even after that time, when we submitted it at the end of 69, it took 2 years until it came out. And there were actually 2 books in the end. The one with the genetics of human populations came out in 71, reprinted in 1999. And then what was really the textbook that I actually first thought of writing, Genetics, Evolution of Man. And I show there the Italian translation, which was published by Mondadori, whom some of you, I'm sure, know about. And I just want to mention a few of the, I think, major contributions in that book that related to Luca's work and that were original contributions. The next slide. We've heard about the Palmer villages, the Palmer Valley villages. And that was Luca's first excursion into really doing actively human population genetics. He used the context of local records and parish records to obtain a lot of information about the demography of the populations of these villages, and then did a blood group study in which he looked at the genetic markers. And he was able to show that the pattern of variation that you found in those villages could be explained just by chance, by what we call genetic drift, and did not reflect at that level of analysis the effects of natural selection. And his studies of the Palmer villages also went into great depth into the issue of inbreeding, and using the records of the Catholic Church to identify people who had consanguineous marriages. And he published much later a remarkable book on that, which I think is not taken enough interest in nowadays, and it really shows that you get quite a lot of marriages between relatives under the conditions under which most human populations evolved in small groups like this, where you inevitably found your mates within your own village or within neighboring villages. And through the stimulus of these studies, the next slide, the next slide is just, you'll be hearing, I'm sure, and have already heard about the studies that Luca did with Anthony Edwards, which were the first studies to show how you could use genetic variation and measuring, in a sense, the genetic differences between populations to get to phylogenetic trees, and how you could use the statistical technique of what's called principal components analysis to cluster populations to show their similarities. And I only show this page because it's, I think, the first case in which that whole approach to analyzing populations that was developed by Luca and by Anthony Edwards appeared in a textbook not very long after they'd done their work. The next slide, I won't go into great detail here, but the idea of studying those Palmer populations led to an approach to understanding migration. Migration in that sense means, what's the chance that if you were born in one of the villages, your parents came from one of the other villages as opposed to the village you were born in? And that's a way you can represent that as a matrix, as we call it, by the proportions that you can observe with respect to the frequencies with which people have parents that came from other villages. And it was Luca's idea to look at this as a matrix, and I helped with the analysis, so you could do an analytical approach to predicting the amount of variability that would arise from this theory, and comparing that with the simulations. And what that shows is that the simulations showed a very good agreement with the theory. And this approach of migration matrices to discuss and analyze the nature of human migration and how it creates genetic variability, I think is still very important, and it's not sufficiently realized the extent to which modern humans, until very recently, lived in conditions that are really very similar to those of the Palmer Valley. Now, you've heard and you saw a lot of pictures of picnics, many of which I have to say I took on the one occasion in 1968 in which, with my late wife, we went to study the picnics with Luca. It was an enterprising endeavor. I'm not sure how many of you know about the time that he had to run away from Idi Amin, who was taking over Uganda when he was studying there, and later when we were, and others who were in the Central African Republic, there was the Emperor Bukasa, who if you went close to him and drove past him on the dirt road to the forest, he'd put you in jail, and I think Luca managed to avoid that. But it was these sorts of studies that of course led to his really magisterial work with his colleagues on the history and geography of human genetics. These are some of the pictures you've already seen. Just the one that's interesting actually is the one on the right which shows Basenji dogs with the pygmies. The next slide just shows, the next one, the way you can represent the distribution of gene frequencies in populations using complex computer analysis, which is something that he did a great deal of later. And then the next slide, since I think my time is running out, shows his famous analysis, and I think Albert Ammerman is here, on how the genetic patterns of change across Europe were consistent with the idea that agriculture actually was migration of people, and he used the complex analysis of Fisher's wave of advance of advantageous genes to explain the patterns of that sort of variation. So this is just a very brief summary of some of the aspects of Luca's very important work, pioneering work in human population genetics, which I had the good fortune to be involved with in him. And there's two people whom you recognize well. And finally, another slide taken of a group of us together, and Eric Shooter and Elaine, who were great friends in Stanford. The rest you will know, maybe not everybody knows Mark's wife, Shirley, and sadly 4 of those are no longer with us. So just to finish and say that I was fortunate to have had a remarkable association over a period of some 60 years with Luca Cavalli. Thank you.